Hi, we're on Chapter 1, Lesson 1, Factors and Multiples. Please turn to page 7. Before we talk about the greatest common factor and the least common multiple, let's talk about the words factors and multiples. A number fits into its multiples. So with the number 12, all we're doing is multiplying up. So in multiples, we are multiplying up. So that would be 12, 24, 36, 48, 60, 72, on and on. Factors fit into the number. So that is going down. When we talk about factoring, we're talking about what numbers make up 12. In this case, we're always looking for prime factors first. When we're looking at primes, always check 2, 3, 5, and 7. Many people forget to check 7. I think it's just because he's odd, but always remember to check 7. So in the case of 12, we know that 1 is prime, so it is a factor. We know that 2 goes into 12. We know 3 goes into 12. We know 2 times 2 is 4, so 4. 3 times 4 is 12. 2 times 6 is 12. And then 1 times 12 is 12. So these would be the factors that go into 12. And then again, how many multiples does 12 have? It has an infinite number of multiples. Now let's go back to the lesson. Okay, so now we have greatest common factor. The key here is the word greatest, which is a number that is a factor of 2 or more numbers. It is the greatest of the 2 or more numbers. The least common multiple is the least number that is a multiple of 2 or more whole numbers. So let's fill in our chart. Greatest common factor, greatest common factor. Now, what are some words for greatest? If we were to see greatest in a word problem, we would definitely see the word greatest, but we might see the word most or the word highest. Common means same. And factors are accomplished through division. So when we think about factoring, we think about dividing. Now let's look at least common multiple. So it stands for, again, least common multiple. Least, let's again think of words that mean least. Lowest, smallest, first. These are all good words for least common multiple. And again, common means same. And then multiple, we will be multiplying. Now let's look at the real world link. Brian is making balloon arrangements. He has 8 blue and 12 green balloons. What is the greatest amount of arrangements he can make if he wants them to be identical? Well, we know that 8 isn't the greatest common factor. Why? Because 8 and 12 don't go into each other. So let's think. 2 is, but can we go higher than 2? How about 4? I think the greatest amount of arrangements would be 4. That means that we'd have 2 blues and 3 greens in each arrangement. Turn the page. Okay, we're going to talk about finding the greatest common factor first. When we're looking at factors, the first thing that we need to do is write all the factors out. So if we have marble, red velvet, and chocolate cake, number of servings 10, 15, and 20, we're going to start with 10. The factors for 10 are 1, 2, 5, and 10. The factors for 15 are 1, 3, 5, and 15. The factors for 20 are 1, 2, 4, 5, 10, and 20. So we know that they all have 1 in common. But is there another number that is higher than 1 that they have in common? You guessed it, it's 5. So the greatest common factor for these 3 numbers is 5. Now, I want to show you another method to determine greatest common factor and least common multiple. It's an upside down division. So we put our upside down division, we put our 3 numbers, 10, 15, and 20. And we look at them and we say, well, we know they're all multiples of 5, so let's put 5 down. 5 goes into 10 2 times. 5 goes into 15 3 times. 5 goes into 20 4 times. Now, we have to look at these numbers, 2, 3, and 4. Do they have something in common, all of them? We know that 2 and 4 do, but does 3 have it in common with 2 and 4? The answer to that is no, because we know that 2 and 3 are prime numbers. So then we circle our greatest common factor. It will always be the left-hand side. Now, if we have a multiple that we can go again, we would multiply those 2 numbers, and that would be the greatest common factor. Now, you try. Pause the video. When you're done, come back. Did you get 7? We know that 7 goes into 49 7 times. 7 goes into 42 6 times, and 7 goes into 21 3 times. When we look at the next level, we notice that 6 and 3 have something in common, but they don't have it in common with 7 because 7 is prime. So we know that the greatest common factor for these 3 numbers is 7. Another method to find the greatest common factor is to do factor trees. When we talk about factor trees, we're determining numbers when multiplied together will get us the number we're looking for. So in this case, we start with the number 12 and 18. So here's 12. We know that 6 and 2 go into 12. Now, I'm going to cross out this number here because it just doesn't help us. Once you hit a prime number, you circle it, and we know that we're done with that number. So now we have 6, which we know there are 2 more numbers that go into 6. That would be 3 and 2. They're both prime, so we circle them. Now we have 18 to work with. So we have the number 18. We know that 9 and 2 go into 18. So again, I'm going to circle 2, and I'm going to cross this out because I like to keep my numbers, once I get a prime, I'm done. I want to leave it there. So then I have 9, and I know that 3 times 3 gets me 9. So then if I write them down, 12 and 18, I know that 12 is 2, 2, and 3. I know that 18 is 2, 3, and 3. Now I have to circle the numbers that they have in common. In this case, they have 2 and they have 3 in common. So I go 2 times 3 and I get 6. Now, again, this is a method you can use, but let's come back over and do the upside down division and see if that works faster and easier. I think it will. I'm actually going to erase this and go just a little bit higher so that I can get it all in, because I know I'm going to need 2 levels here. So I have the number 12 and 18. I know they're both even, so I'm going to put a 2 down. Okay, that was the bell. So 2 goes into 12 6 times. 2 goes into 18 9 times. Now I have to put another division bar down. And I look method 6 and 9, and I know that I can pull a 3 out. 3 goes into 6 2 times, 3 goes into 9 3 times. Now, 2 and 3 are both prime, so I know that they can't go into each other, so I'm done. And I know GCF is always on the left. So all I have to do is put a multiply dot between them, put my equal sign going down, 2 times 3 is 6, and I'm done. You now have two methods to determine greatest common factor. Pick the one that works for you. Pause the video. The greatest common factor for 12 and 66 is 6. The greatest common factor for 18 and 30 is 6. And the greatest common factor for 32 and 48 is 16. Notice I put the prime factors for each of those. Turn the page. Alright, now we're going to look at least common multiple. And remember, in multiples, we're multiplying up. Now, in method number 1, we're looking for the least common multiple of 2 and 3. In this case, they've done a number plot with x's. I don't really like this method, so again, I'm going to teach you how to do it with the upside down division tree. It also works very well. So we have 2 and 3. We know that they're both prime, so 1 is the only number that they have in common. And we write down 1 goes into 2 2 times, 1 goes into 3 3 times. Now, the cool thing about least common multiple is that you make an L. Does everybody see my L? These all get multiplied together. So we have 1 times 2 times 3, which is 6. So we know that the least common multiple of 2 and 3 is 6. You can also use method 2, which is just making multiples of the numbers. In this case, we have 2. 2, 4, 6, 8, 10, 12. For 3, we have 3, 6, 9, 12. Now, we know that 6 and 12 are both common, but we want the least, which means the lowest. In this case, that would be 6 again. So both methods work. I like the upside down division. Now, in example number 4, they're going to use prime factorization. While you can do this, it gets confusing because you can only use the numbers once. But when you have multiples of those, then again, it starts to get really confusing. So I prefer the upside down division. Let's look at the numbers 14 and 21. We know that each have 7 in common. 7 goes into 14 2 times, 7 goes into 21 3 times. And there's nothing, 2 and 3 are prime, so I'm done there. So I come down, I make my L. Again, does everybody see my L? I put my multiplication dots. I have 7 times 2 times 3. 7 times 2 is 14, times 3 is 42. So again, I know that my least common multiple is 42. Get it, guys, go. I suggest you use the upside down division tree. Pause the video. Okay, for E, 2 and 6, the least common multiple is 6. F, for 4, 5, and 10, the least common multiple is 20. And for G, the least common multiple is 105. I know that because 3, 5, and 7 are all prime numbers, and the only thing I can do with them is multiply them together. Turn the page. In the example of real-world problems, the hardest thing is to determine whether you're finding GCF or LCM. In this case, because we're looking for when they see each other again, we're trying to multiply until they get up. So this would be an LCM problem. In this case, the answer would be 10 weeks. Please do the guided practice. Pause the video. All right, look over my answers and see if you got the same. 1 is 8, 2 is 12, 3 is 3. They were all GCF. 4 is 63, 5 is 30, 6 is 180. Those are LCM. Problem number 7 was also an LCM problem. And in greatest common factors, you're looking for arrangements. I will be giving you a handout so you can use. See you.